easy for me to like analyze. No, springs are in series. You guys know, no? What will be the equivalent spring constant?
1 upon
One
K.
upon 1 plus 1 upon K.
So actually, you guys can solve it. So here M will be there. Here M will be there, and this is like being pulled with some constant force F. What is that force, guys? Mg only, no, weight. I'm converting that block into horizontal system. Mg. So what is the net force acting on the system?
0.
0, right? So net force acting on the system is 0. So basically, then if we are slightly displacing and then leaving it, so it is going to do an SHM. Okay. And with what time period is going to entire system is going to do SHM? Can you guys tell? Reduced mass concept, do you guys know?
1 upon
2
mu
pi
is
root
equals
2 pi root mu by k. This is the concept, right?
yes.
You guys know this? Mu is what's the reduced mass, which is given as m1 m2 by m1 plus m2. In this case, what is the reduced mass? M by 2 you are going to get. And similarly, what is K equivalent, sir? K equivalent is
2K by
2K by 3 you are going to get. So you just substitute here and you are going to get the time period. Time period of like whatever like oscillations of this one you are going to get. Right? And what they're telling? Maximum displacement of A and B will be same in downward, means like right side and left side, but the two springs will have different extension at that instant. So let us go on to the center of mass frame, and if we solve, net force on this one is 0. So obviously the center of mass shouldn't be like moving, no. So according to that, tell me whatever the displacement it is traveling, same displacement it should travel or not. If they travel different displacements, what will happen? Because they are same masses, then tell me center of mass will move or not. But center of mass shouldn't move, isn't it? Understood what I'm telling? That means whatever the distance it will travel, same distance it should travel. But for the same distance to travel, okay, let's say imagine, see now you'll get clarity. Let's say this is traveling a distance of x, m. This should also travel the same distance of what, sir? X. Okay. This will also travel the same distance of x. So now imagine that this is connected to a spring of what? K. This is connected to a spring of what? 2K. Now again go back to the normal thing, K and 2K. So if the extension is x, okay. So now extensions are displacements are same, but what they're asking about, maximum displacement of A and B will be same. That's fine, because then only center of mass won't change the downward direction, but the two springs will have different extensions at that instant. So let us find about extensions. How to find about extensions? No, both are moving by the same distance, no? And extensions, will it be same? No. We cannot tell accelerations will be like different. 1 second. Then accelerations will also be same, right? Accelerations will also be same. Yeah, see here how the extensions will be different, you'll understand. Tell me, for the acceleration of center of mass to be 0, both should have the same acceleration. Let's say this got an acceleration ACM, A right side, A naught. This should get an acceleration A naught left side, isn't it? Why? Because the acceleration of center of mass must be 0. If that is the case, mg for this free body diagram is what, sir? Mg minus extension kx, and for this on this one force is what? 2kx1. I'll take 2kx2. So mg minus kx1 will be equal to mass into acceleration a naught, and for this one mg minus 2kx2 will be equal to ma naught. Is it clear what I have written? Now tell me the extensions will be different or not? Kx1 will be equal to 2kx2, right? That means
Yes.
x1 will be equal to 2x2. Then that means extensions will be different in the springs. Don't get confused. But sir, earlier you told if this is moved by x, this will also move by x. Yeah, that is like the distance that is moved by block M and this block M on either sides. But for that, I didn't told what extensions that they are like covering. Okay, understood? But center of mass should be at rest means acceleration of center of mass will be zero, as both the masses are same. Whatever the acceleration that will be there on this one, same acceleration should be there on this one. Draw the free body diagram of this one. For this, what spring is connected? K spring is connected. So mg minus kx1. Assume that x1 is a spring extension. Here 2k spring is connected for this one. 2k into extension, let's say x2. So net force equal to mass into acceleration. So when you equate these two, this is what you will be getting. So x1 equal to 2x2. Is it clear?
Yes,
Yes,
sir.
sir.
Okay. So I hope I have